Welcome back to DGIPCORE Channel. Today we are unboxing the NVMe IP, the number one IP core form design gateway. It is a high-performance solution for FPGA based NVMe storage, designed to be ready to use without any effort to understand the NVMe protocol. Now let's go take a look what's inside the package. Once you unzip the package, you will find the three main folders: Document, IP core, and Reference Design. We will focus on the Reference Design folder. It is designed to help you reduce development time and get NVMe IP running on your FPGA as quickly as possible. Now that we are inside the Reference Design folder, you will see 5 folders: Download, HDL, IP, Software, and Work. Let's start with the Work folder. Inside this folder, we have already prepared a complete Quartus Palm project, so you don't have to set up anything from scratch. This project is set up for you to modify, customize, or use right away, saving time and effort in development. With this, integrating NVMe IP into your FPGA workflow has never been easier. Okay, let's move on to the HDL folder. Inside you will find the 6 VHDL modules. These 6 modules are the key parts of the NVMe IP reference design. To help you understand this module, we have provided a free reference design document on our website that will explain how each module works. As you can see, every module in this folder is documented in detail. This means that for every module here, you can find a detailed explanation in the document. Let's take a closer look at one of these modules, the TestGen. This module plays a key role in the reference design. Let's check the entity signal of the TestGen. The FIFO interface is the important part of how TestGen communicates with the NVMe IP system. You can see how this part is structured in both the code and the document. Here is the main process inside the TestGen, and in the documentation you will find a detailed explanation of how it works, along with the timing diagram that shows its operation. Now let's take a look at the software folder. In this folder, you will find the firmware code that we provide, already integrated into the reference design. On the left, we have the firmware source code, and on the right, we have the documentation that explains its operation. This main function is where the key operation of the firmware takes place. The document provides a detailed breakdown of each step, ensuring you understand how it interacts with the NVMe IP. Here is the list of key functions used in this firmware. Each function has a clear parameter description, and you can refer to the documentation for a more detailed explanation. With this, you can quickly locate and reference any function when working with the firmware. To make things more convenient, we have documented of how NVMe IP works in the NVMe-IP DataSheet document. This document provides a detailed timing diagram to help you understand how each operation works. The diagram shows the exact sequence of operation for NVMe IP, making it easy to follow each step. Now, let's check out the download folder. Inside, you will find the SOF file, which is used to program the FPGA board. And here is the best part. Not only our customer who purchase our IP can access this file, but you can download it and take it for free too. Just visit our website, go to the free Evolution demo section, fill out some basic information, and you will get access to the SOF file completely free. With this, you can try NVMe IP on your own FPGA board before making a purchase. Now, let's move on to the demo setup phase, where we will run the NVMe IP on the latest Sulfur Agilex 5 FPGA board. This board features Intel's newest Agilex 5 FPGA, delivering next generation performance for the high-speed application like NVMe storage. For this demo, we will connect the FPGA to the NVMe M2 ASD using our AB19 M2 PCI adapter. But don't worry if you don't have the exact FPGA board, we got you covered. Inside our FPGA Setup Document, we provide a basic setup guide for multiple FPGA boards. So, even if you are a beginner, you can follow this step and complete the setup on your own. With this, anyone can get started with the NVMe IP, no matter which FPGA board you have. Now that we have successfully programmed the FPGA, let's run the line command to measure the performance. And here is the result: 3100 MB per second write speed. This is an improvement over the previous FPGA board, where the write speed was around 2900 MB per second. This performance boost is thanks to the new hard IP that comes with Agilex 5. There are still more features available in NVMe-IP demo. For a detailed breakdown of every menu option and its secret, you can refer to our instruction document. This document provides a step-by-step guide on how to use each command, making it easy to follow and experiment with NVMe-IP demo. And that is, we have unboxed the NVMe-IP, explored its reference design, and set it up on the latest Agilex 5 FPGA and test its high-speed NVMe performance. Don't forget, we also provide the full documentation for free on our website, so you have everything you need to get started. For more details, feel free to reach out to us with any question, and we will see you in the next video.